going to record in here. And let me do share screen, okay. Where is, oh. Okay, so the first chapter is introduction about AI. So the major topics we are going to discuss is what is AI? Is it it's a buzzword? We almost hear it every day, is it? And some examples. But here's the example provided. It's probably still not the latest one. Okay, but anyway, let's go over that. And here is a definition for the AI from our textbook. Okay, and if you see it, it's kind of 4 quadrants, the 4 components. And if we, so there are 2 sets of words. One is human versus rational. Is it human versus rational? That's one aspect. The other aspect is think versus acting. Okay, it's thought versus behavior. That is thought versus behavior. So generally speaking, that so the AI is going to cover this human and rational and thought versus behavior. Okay, and if you think deeply, like here, my notes says, so for the human, okay, so the human intelligence, normally it's more related with what? It's kind of psychology. Is it? So psychology or cognitive science, like those. So in that part, it's human. Okay. On the other hand, it's the rational. So when we say rational, what does that mean? So rational, it's more like, it's not just logic, it's rational. So it's more like the scientific field. So like here it's mathematics, engineering, is it? And statistics, and for machine learning and deep learning, heavily counted on statistics. Okay, heavily counted. And the control theory, and also control theory, like neural network, part of like started with the control field. Okay, like a feed forward network, okay, neural network. So control theory and economics, later on we will see. Okay, we try to maximize the gain. Okay, like machine learning reinforcement, okay, the award. Okay, so all this is regarding rational. So that's why the human and the rational. Okay, so human is more psychology. Okay, so that's different field, is it? And the other part is what? It's thought and behavior. Is it thought and behavior? Okay, so AI also a lot of time you try to mimic like robots. Is it? Try to mimic. Okay, so you try to mimic a brain. Is it? And then you demonstrate certain behavior. Is it? So for this field, then you need to also know like what the human's behavior. Is it? So that's just the textbook is the definition of AI. Okay. And so one of the components said think human. Is it think human? So think humanly, now we have some field to study human, like cognitive science, neuroscience. Is it? So these study, because this study bring us information processing. Okay, but even that science, if you want to truly understand how brain work, it's still a lot of work. Okay, we still haven't got to fully understand that. Okay, so that's and now normally it's what? Normally the process is through introspection, psychology, experiments, and the more rational like brain imaging. Is it brain imaging? You can use MRI, use the X-ray, use also to do the brain imaging. Okay. So this is think humanly. Okay. So then the next question you see, can we build a brain? Is it? And now we know like the computers. Is it computers? And the brain is different, but we try to mimic. And when we get to machine learning, like deep learning, the foundation is neural network. The starting point of neural network is try to mimic human brain. Okay, that's why we call it neuron. Okay, we have neurons try to mimic. And here it gives a comparison table. Okay, about a supercomputer, personal computer, and the human brains. Okay, using like computation units. And with computer, supercomputer, we have CPU, we have transistor, we have RAM. But with a human being, with a human brain, then the only available thing is neurons. Okay, neurons. And if you take a look at the storage unit, so the storage unit for supercomputer is RAM and disk. Is it? So external storage, the hard disk and the RAM, memory. Is it? Those are the computer. And for human being, for human brain, it's neuron and the synapses. Okay, those are that we use to store information. Okay, and the cycle time. If you take a look, the cycle time basically computer faster than human brain. Is it much faster than human? That's why when we do, if you just do number calculation, human cannot compete with computer. Is it? That's why AlphaGo, once it's trained well, they can beat a human brain. Is it? So that's the cycle time and the operations per second. And if you take a look at the operations per second, the human brain, you can see, is not too bad. Is it? It's better than personal computer. Okay. Okay, so that's regarding human brain versus machine. Okay. The next one is discussing some like initiative. So you can see like US, that's back as I remember decades ago. It's back in President Obama era, has the brain initiative. Okay, so the brain means the brain research through advancing innovative neurobiology. Okay, so that's the brain initiative. And we also have human brain project. And Europe have their initiative. Okay, with the human brain project, it developed two fields. One is called the neuromorphic, and the other is neurorobotic technology. Okay, so that's a human brain project. And here, this slide gives a brief description about neuromorphic engineering and neurorobotic engineering. Okay. And for the neuromorphic engineering, a couple of things I want to mention is over here, it's a training software-based neuromorphic system. And here it mentions a neural network called the spiking neural network. Later on, when we learn deep learning, we will see we have ANN, CNN, and RNN. Is it? And for this, basically, it's SNN. Okay, it's called spiking neural network. Okay, and it's through arrow back propagation. And for neural network, if you study from the starting point to understanding, it also uses, it's called the keyword back propagation. So it's kind of mathematical derivatives, very kind of complicated, okay, to understand. And it also said use Python-based framework called SNN Torch, okay. And for deep, we have TensorFlow. Is it another quite popular framework for deep learning is PyTorch? Is it? This is SNN Torch. Okay. And this is more using biological learning. Okay. So this is regarding neuromorphic and neurorobotic. Then it's understanding. So it's a combination of neuroscience and robotic and artificial intelligence. Okay. And right now, I remember I saw a video said you can do like in medical field, you can use robotic to do surgery. And the remote, that's the latest one, is it? And very precise. And this is going to be very helpful, especially during the war, because some famous surgeons, they can just, remotely do the surgery. So in the past, that's unbelievable, is it? But now you can do that remotely. Just think of how cool it is it? Okay, so that's regarding the Brain Initiative. And what the next one is, you remember we thought about human source. So how do we study human source? Is it? So here is the three approach. Introspection. So what is introspection? Introspection, you catch your own source. Okay, so like sometimes we do some reflection, is it? You also summarize some of your own thoughts, is it? So that's called introspection. The second is called psychological experiment. So that's not yourself, that's for other people. You observe other people. Okay, so that's psychological, it's psychology. Okay, and through study psychology, that you can generalize a lot of psychological behavior. That okay, the third one is more scientific, like STEM related. Is it? It's image. It's you observe the brain in action, and then try to analyze the thought process. So I still, because I haven't learned neuroscience, so I still cannot understand how that works. Okay, but looks like this also works. You observe the brain in action. Okay, because how can you use the image to know what the people thinking? Is it? Yeah, just based on the signal. How? Yeah, still but looks like there's some movement. Okay, can be done in that regarding. Okay, then the next one is about still thinking humanly. Is it? thinking humanly. And here is a key point. So from these two famous scholars, Allen and Herbert. Okay, Allen Herbert, they developed the GPS. Be careful. Here, this GPS is not the navigation GPS. Okay, this is called general problem solver. Okay, general problem. We are going to cover it also. Okay, general problem solver. And the general problem said it's not that important that you have the program solve problem correctly. So that's not the aim, not the goal. So the goal is what? You compare the sequence of timing of the reasoning steps to people how solve. So what you care is not the end result, is it? You care about the whole sorting process, the logical process. Because if you understand this, then you can let your machine to mimic what your sort of process is. Otherwise, you just based on the problem, it's hard. Okay, that's why if you after we learn the concept of machine learning, you will also say it's kind of based on the training. That's why we call it training. Is it based on data set, and you do train, and then let it to reach the goal, get closer and closer to the target. Okay, so it's not you just have the problem solved. It's the sequence and the timing of the analysis. That's very important. That's very important. That's also the difference now between machine and the human. Is it? So that's why right now, even with so advanced AI, they still cannot reach a person's intelligence. Even though at some respect, they already surpass humans. Is it like computation capability? Is it far? That's because of the hardware. Is it? Okay, so that's regarding this part. And the next one is about Turing machine. Okay, and the Turing test. Is it a Turing test? And Alan Turing, we all know he is a genius. Is it in CS field? Okay, so remember this, Alan Turing. Okay, he was a genius. Okay, got a lot of inventions. Okay, including encryption, decryption, is it for the World War II. So he has a paper called Computing Machinery and Intelligence. In that paper, he proposed the Turing test. And the Turing test, this concept, discussed a lot in computer science field. Okay, in computer science field. So what is the Turing test? So the Turing test basically is you have some written questions. Okay, then you give a human and a machine. Okay, and it's blocked. And the human and the machine give you reply back. And you decide if you can make a distinction between the answers from human or from a machine. If you cannot, then that means that machine is already reached human's intelligence. That if you can, then that means the machine didn't pass the test. Is it? So this is called the Turing test. Okay, very famous. So if in the future people talk about it, okay, like when you go to interview, just chat the Turing, what is, you should know, okay, what is Turing test, because That's discussed a lot in computer science. And also remember Alan Turing. Okay, he was a genius. Okay, so is this. And then here the question said, what capability would a computer need to have to pass the Turing test so that you cannot distinguish, etc. So here, definitely you need natural language processing. Okay, and right now, ChatGPT is already quite powerful that I tested, but still, it's not like a human because some of the speaking patterns or questions the ChatGPT never saw, then it cannot answer well. The answer provided, no, it has no sense, you will see. Is it? Because anyway, it's still machines based on the training. But if you think this is same as a human, is it? Just think about when you were little. If I ask you about Turing test, you also don't know. Is it? Then definitely the answer you provided will doesn't make sense. Is it? But when you grow and you learn more, gain more knowledge, then your answer more reasonable, more sense. Is it? So similar. Is it? So the natural language processing plus knowledge representation. So your knowledge base also very important. Is it? So similar, you see, like a machine, we also do training. We train what? We train this knowledge. And basically it's data set. If you guys already learned my CS that data analytic, you know of those data sets, basically that plays the role, very important role to do the training, okay? And but still automated reasoning. So reasoning, I think, for human, we based on our experience, our knowledge, etc. We then can develop our own unique reason, is it? But how machine can develop this automated reasoning, is it? That's maybe a little bit of hard, is it? Okay, and machine learning. So with this 4 aspects, then says if a computer own these 4 aspects, capability, then it can pass the Turing test. Okay, and the Turing predicted by 2000, machine would be able to fool 30% human judges for 5 minutes. That's what he predicted. But I didn't research if that's true or not. Okay, if you have time, let me know next class. Okay, if 2000, but I remember at 2000, at that time, that's this field, AI field, still kind of in the dark. It's not, it's AI field, it's recent, especially recent, like probably 5 years or something, it's boomed a lot. Yeah, it's with the machine learning and deep learning. It's also based on the hardware. Okay, and because the available resources to do that kind of training. You see, like for ChatGPT, and I remember I read an article. I don't remember exactly how much like watts it will consume the electricity, but it consumed huge amount of electricity for ChatGPT. Yeah, it's because the training takes a lot of power. Okay. Okay, so that's about a Turing test. And here says the potential problem with the Turing test. What is that? Human behavior may not intelligent. Yeah, that is true. Not all of human behavior is intelligent. Is it? Sometimes human can also be kind of, yeah, you see, not that intelligent. Okay. And also said intelligent behavior may not be human. Yeah, that's true. Is it? And the human observers is it may be easy to fool. Is it? Yeah, that's true. We also got a scam. Is it? Email scam, all sorts of scam. Is it? So he says a lot depends on expectation. Is it? Anthropomorphic fallacy and the chatbots. And also there is a thing called Chinese room argument. Is it? So that's some potential problem with a Turing test. And the next is passing Turing test a good scientific goal? Okay, and it says not a good way to solve practical problem. It can create intelligent agent without trying to imitate humans. So that's just some regarding this Turing test. Okay, the next one is about thinking rational. Okay, thinking rational. Here it says, what's the idealized way of thinking? Okay, and here the thinking rational, so the starting point is the logic. Okay, and I don't know if when you guys learn math, I remember that's when I was in middle school, learn math, you needed to learn how to prove theorem, is it? And in that you have assumption, is it? Something like that. And so just like here, it says the logic. Logic is what? Is patterns of argument that always yield correct conclusion. So the conclusion is based on some assumption. Is it? Or some universal law? Okay, something like that. Okay, then we have the logic. When is that when supplied with correct premises. Okay, this premises, some just universal law. Okay, based on human human histories, experiences, etc. Yeah, you cannot prove everything. There's some just universal. Okay, and so the logic. So probably the founding father is like Socrates, like Aristotle. Is it Aristotle? The philosophy. Is it philosophical thing? Is it? So something like, so here to give an example, it says Socrates is a man. All men are moral. Therefore, Socrates is mortal. So this kind of logic. Is that in math, some of the math proof is kind of like this. Is that, yeah. And it's beginning with Aristotle. Is it? Philosopher and mathematician have attempted to formalize the rules of logical thought. Okay, logical thought. Yeah, you see why I said those people are great. Because for us, a lot of time we never thought of this. Is it? It's kind of so you just, but for them, they will, even with our regular thinking, they will go deep to think about it, and then kind of find some pattern and provide some scientific, logic analysis. Is it? Yeah. Okay, so it's that logistics approach to AI is you describe problem in formal logical notation and apply general deduction procedure to solve it. Okay, this is called thinking rationally. And it says problems with the logistic approach is the computational complexity of finding the solution. Sometimes it's too hard. Okay. And also sometimes describe real-world problem knowledge in logical notation. You may not it may not be easy to do that sometimes, the real world. Is it? Not everything you can present in a logical way. Sometimes it's itself just chaos. That's why there is a field called chaos engineering. Okay. And the third one is a lot of intelligent or rational behavior has nothing to do with logic. Yeah, that is true. Is it? It's not. It's not everything rational is logic. Okay. Okay, and acting rational. So that's also the component for the definition of AI. Is it? So rational agent acts to optimally achieve its goal. Okay, acting rational. So rational goal is to optimally achieve its goal. What is goal? So goal is that application dependent and expressed in terms of the utility of outcomes. And some of, and I believe of you right now in CS field, is it? Just think about the path finding in graph, the shortest path. So the shortest path, like digester algorithm, you see, is a Behrman-Ford algorithm. What is it? They try to minimize cost. So that minimize cost basically is what? Is your goal. Okay, is your goal. So then you will act rational based on that goal. Okay, so that graph search, okay, basically it's kind of related with the utility of outcomes. Okay, so here it says being rational means you maximize your expected utility. So maximize utility, is what? You minimize the cost when you do the path finding. That's one of the simple case right now I can give you. Okay, so think about this. We all know that. Is it the shortest path? The shortest path, we based on what? We use cost. Is it the cost definition is based on what? Is time or money or whatever? Is it anyway in graph theory? Is it? So later on we will see this. Okay, like A-star search. Is it? Especially with machine learning, like the reinforcement learning. The goal is try to reach this utility of outcomes. Okay. So here that this definition of rationality only concerns the decision actions that are made, not the cognitive process behind it. That's true. Is it? This is true if you deeply analyze this. Is it? And as in practice, utility optimization is subject to the agent's computational constraints. Yes, yes. And it's bounded rationality and bounded optimality. Yeah, that is true. It has some constraints, computation constraints. Okay, and then next is discuss about utility maximization formulation. Okay, the advantages and the generality. Okay, so this discuss goes beyond explicit reasoning and even human cognition together. Okay, the second advantage is the practicability. Is it? So this can be adapted to many real-world problems. The next naturally accommodates uncertainty. Yes, because just think when you do path finding, is it you don't know? Is it like a maze, going maze? Is it you use the algorithm? Is it? But that's uncertain. Is it? That's like for game design. Is it in game design? You use a lot of like algorithm. Is it a search? That's with uncertainty. Is it? And the next is amendable to good scientific and engineering methodology. Yes, because the cost, minimize cost or maximize your utility. It's not, you need to have some math formula to define them. And we call it a cost function. Like when we do path finding, we minimize cost. That's cost. But later on with machine learning, we specifically define the cost function. Okay, cost. I remember even with A-star search, we have that cost function. Okay, so cost function is quite important. Okay. And it says avoid the philosophy and the psychology. Yes, because this is more what? Rational. Okay. It's not human. Okay. So with rational, it's needs math. Okay, needs math. As it prevails in other fields, this utility maximization formulation, control theory. Control theory is try to minimize cost function. We will also see, like the neural network, it's also to minimize the cost function. Okay, and we will see it's like the bowl. Okay, and we always try to find the bottom of the bowl. Okay, regarding the mass curve. Okay, and regarding economics, it's maximize expected utility, of course. Is it regarding economics, like GDP, you try to maximize? Is it for your stock return, you try to maximize? Is it? So that's regarding that. And operation research maximize the sum of the rewards. Okay, yeah. And statistics, it's minimize the loss function. Okay, so of this. Okay, so this is regarding utility maximization formulation. And the disadvantage of that is that it may be hard to formulate utility function. Yeah, that's true. How do you find the cost function, the utility function, the loss function? That's very hard. So that's why right now with AI field, mathematician is very, very important. Okay, so how do we provide the utility function? Okay, it says especially for complex open-ended tasks. And the next is that AI may end up gaming the utility function, and its operation may have unintended consequences. That is true. Yeah, because machine is not like a human, is it? It's just based on that function, is it? So it may game. Okay, so that's why for AI, the ethical is also a big issue. Yeah, just think about if in the future you get some robotic that has competitive intelligence as us, will they still listen to us, to human command? No, they may command us. That's possible. That's very possible. Okay, so. And the next disadvantage has limited applicability to humans. Yes, this is true. Yeah, so that's about utility maximization formula. And here is a link called 10 difference between artificial intelligence and human intelligence. And this slide is on our course website. So this difference, if you are interested, you can read, okay, after class. And what next is about AI connections. We already discussed of this general ideas, so you may already kind of get of this. Philosophy, is it? That's definite, is it? Because it's discussed logic, reasoning, is it learning, knowledge? Yeah, philosophy plays a role in AI. Mathematics, then definite. All of current, the deep learning, even ChatGPT usage just words, but behind it's all mathematics. Yeah, it's all mathematics. Okay. Economics. Yeah. Economics, like the utility, like decision theory, also plays some role in AI. Okay. Neuroscience, the biological basis of intelligence. Okay. Cognitive science is the computational model of human intelligence. Yeah. Linguistic, the rule of language acquisition. Yeah. So like for natural language processing, like ChatGPT, they need to also consider this linguistic. Okay, it's not just a word. And which word first, which word next? And combine what's the context? Is it word, phrase, paragraph, all of this? Is it? Yeah, so that's regarding linguistic. Okay. And also like translation. Is it AI translation? Okay. And the machine learning. Machine learning is designed that use experience to improve performance. Yeah. Because based on you can predict, is it? And you can ask a machine to do image recognition. Is it? Right now, it's just not images, it can generative AI. Okay. And I know I haven't tried mid-journey, but I tried with OpenAI's Dell. Dell is not, looks like the performance is not that good for image. Though it's ChatGPT is fantastic, but the image functionality is not that good. But mid-journey, you need to use the Discord channel to use mid-journey. Mid-journey can generate a very cool picture. Yeah. Okay, the next AI connection about control theory. Control theory is a design of dynamical system that use a controller to achieve desired behavior. Yeah, like what? Like a motor. Okay, like a machine motor, your car motor, like a airplane motor. All of those motor need a control theory. So behind it, it also has like the neural network kind of complicated system. Yeah, it's not like what we think it's easy. Okay, there are a lot of complicated systems behind that. Computer engineering, mechanical engineering, robotic, is it a lot of stuff? Okay, and what's the next? Let's get a brief look of the history of artificial intelligence. This is based on Turing Award. Okay, you can see Alan Turing's role in computer science. Yeah, Turing Award is kind of like the Nobel for other science in computer science, the Turing Award. Okay, because computer science is not included in Nobel Prize. Okay, because I believe at Nobel, when Nobel design that award, the computer science field didn't exist. Is it? Yeah, see this Turing Award winners. The first is called Marvin Minsky and John McCarthy. Okay, so their definition for the foundation of the field based on representation and reasoning. Okay, so the next is Ed and Reg for developing, it's called expert system. So expert system is also part of AI. Okay. And the next one is probabilistic learning. This is also very, very important in machine learning in the current AI field. It's all based on complicated statistics. Okay, very, very important role here. The next one is Joshua, Geograph, Hinton, and Yaler Khan. Those are the current big guys in AI. And who knows this? The Hinton? You know, OpenAI. Yeah. OpenAI basically the founders And I believe he himself also involved with OpenAI. Yeah. And you guys can Google him. Okay. And OpenAI, some or not if not founder, then probably the major scientist in OpenAI. So the foundation of generative AI for OpenAI company, the OpenAI application is his ideology. Okay, so his AI branch. He and him, you guys can search. Two different kind of idea is not the same. Okay, and Yan LeCun, he is a professor at New York University, computer science. Right now, he is also the chief scientist for Facebook. So he disagrees with Hinton in their research area. Okay, so Yan LeCun, and right now Facebook, it's better. The Facebook, their AI fell behind. And that in the open AI, this generative AI competition, they fell behind. And that yeah. So if you read some articles, you will find some interesting stories about these two current. Okay, Hinton and LeCun. Okay, those are the two biggest guys in AI, in machine learning. A lot of interesting stories about the generative AI. Okay, they are different views. Okay, one didn't agree with, but yeah, but OpenAI ChatGPT, it's surprised everyone. Okay. Okay, let's give some history. Okay. And the first is probabilistic reasoning and machine learning, 1987 to current. Okay, and here there are some, we call it shared benchmark problem sets. And in this field, we should know of this. Okay, otherwise in the future, if you want to go to the, you even don't know that, that's not, doesn't look good. Okay. And one is UC Irving's repository for machine learning data sets. Okay, so some classical ones. Okay, whenever, so all of the students in machine learning field get some data set from this repository. Okay, UC Irving's. You can search, okay. The next is the international planning competition for planning algorithm. The next one is Libre Speech Corpus for speech recognition. So for natural language processing, we call them corpus. So it's some standard data set, some articles basically. Okay, some plain text. Okay, plain text. Okay, some paragraph, some article, you know, those we call them corpus. Okay, here. The next one is the MNIST dataset. So MNIST dataset is what? Is handwritten digit, 0 to 9. Okay. And the next is ImageNet and COCO for image. Yeah, for image, they also have some starting point dataset standard. So every research starts with those. Okay. And the SQUAD for natural language question, and WMT for machine translation, international set competition for Boolean satisfactibility solver. Okay, so those are the probability. Yeah. Oh, I include the Stanford AI index report in my slide. Okay, here. Some examples. I'm not sure if you guys know, because this is quite some time ago about IBM Watson. Okay, And at one point, it wins on Jeopardy. Okay, and you know the Jeopardy show? Yeah, the IBM Watson wins on Jeopardy. Okay, so that's why I think machine definitely can beat human. That because those are just historical facts. Yeah, human you cannot remember everything, but machine, okay. Once you feed it, okay, and self-driving cars. Okay, so here it gives Google self-driving. Yeah, when it's interesting, you read it, okay, because then you kind of understand how autopilot works. It uses some devices. Okay, so I recommend you read it after class. Nature language, and right, this is still old because I didn't include ChatGPT. That's the number one I I can see that bit of this. And the vision is the basic is OCR. So what is OCR in computer science? Represent optical character reader. Okay, handwritten recognition. Okay, face recognition. And the games, we know AlphaGo. Is it? You all know AlphaGo. Is it? Beat the Grandmaster. Is it? We know that story. And the mathematics. This is also quite interesting. Is that the computer even solve an unsolved question for decades. That's interesting. Yeah, it can also do derivation. This is amazing. Yeah, because that's also quite useful. In the future, it can help solve a lot of open questions. That's going to be very useful, okay? Logistics, scheduling, planning, here to give some examples. One of interesting is the DARPA Grand Challenger. You can read it. Yeah, the DARPA robotic challenger, but that's back almost a decade ago. And the information agents. And we also use quite now, is it in our system? Search engine recommendation system, spam filter in our email, is it automated help desk, medical data fraud detection, automated trading, is it? So here give example. And robot like we just mentioned, the remote surgery in their surgeon, that's more powerful than this. Is it? Because this is still kind of old. Okay, and the deep sensory motor learning, etc. So this is also kind of old. Okay, so how do I stop sharing? Okay, let me stop